right, so continuing with lesson 11.1. Now what this is right here is this is from the previous page, but we're going to read it together. So in a circle of radius 1, so let me add in a radius here and mark it as 1. The radian measure of a given central angle can be thought of as the length of the arc associated with the angle. So let's just put in a random angle, 45 degrees. It says that the radian measure of a given central angle, so here's my central angle, can be thought of as the length of the arc associated with that angle. So what they're saying here is, what we've done so far is we've measured, we said if the central angle is 45, then this arc length is 45. Well, there's another way to measure it, and that's in this unit called radians. Just like 12 inches is the same as 1 foot, different units to measure the same thing. Here, we can measure something in degrees, we can measure something in radians. Then maybe you remember that from maybe possibly when we did sine, cosine, tangent. If you use Google Calculator, or maybe your calculator was set in the wrong mode, you may have been getting the wrong value and thinking, well, what is this whole radian idea? This is what it is, okay? Now, it's a good name because, again, the radius is 1, radius, radian. So that kind of all connects. But here's what we want to do. We want to keep in mind the key to a radian is that the circle has a radius of 1, okay? Now, with that in mind, think about how many degrees go around the whole circle. We know 360, right? Now think about that whole distance around. If we're saying that a radian is equivalent to the measure of that arc, excuse me, what is the measure of the entire arc? Well, that's around the whole circle, aka the circumference. Okay, so that's circumference. And now the circumference is 2 pi r, and the radius here is 2 pi times 1, so we just get 2 pi. So what we find is that the relationship between radians and degrees is going to be 2 pi equals 360. All right, and that's what they have down here in this block. So I know they say degrees and radians, but anyway, the same ratio. It doesn't matter what's on what side of the equal sign. So they wrote it like this. They write 2 pi radians for 360 degrees, 360 degrees for 2 pi radians. So it's the same thing. The reason they have two different ones is because sometimes you're going to be given degrees and you're turning it into radians. Sometimes you're going to be given radians and you're turning it into degrees. Okay. All right, so now how do you know which one to use? Well, the nice thing is that the ratio is always the same. 2 pi is the same as 360. As long as you have that in your head, then you're good to go. Now, you can also simplify it. Doesn't 2 cancel out into 360, and can't you rewrite that as 1 over 180? Well, that's what they did. So this second thing here isn't necessarily needing to be memorized. It's just a simplified version. I'm going to use the original one just so that we can emphasize, especially in this setting, emphasize what the ratio is. So whenever I work through these next problems, I'm going to use this just to really bring home the idea that 2 pi radians is equivalent to 360 degrees. It's that arc length around the circumference equivalent to the degrees around 360. Okay, now how do you know which one to use though? Coming back to that question, let me give you something we know. Let's say 3 feet. If I asked you to turn this from feet into inches, we all know 3 feet is 36 inches. But if we use something called a conversion factor, which is really what these are up here, I would say that I need to put inches over feet, because what I'm going to need to have happen is that my feet units have to cancel out. So I'm just left with inches. So when I do conversions, my numerator and denominator have to be the same unit so that they cancel and eliminate. Okay, so then I just fill in the values. There's 12 inches for every 1 foot, multiply straight across, and we get the answer that we already know, 36 inches. Okay, so we're going to keep that same process in mind whenever we go to convert. So here's what I mean. For letter A, convert 45 degrees to radians. So I have 45 degrees. I want to turn this into radians. So I have to have degrees in the denominator so that my degrees will cancel, meaning radians is in the numerator. So now all I have to do is substitute in what those units are. We know that there's 2 pi radians for every 360 degrees. And that's all there is to it. Okay, so I can multiply straight across. I can cancel, cross cancel. Again, I'm not using the most simplified version. You can, but I just want to bring home the idea of 2 pi for 360. So because of that, there's going to be more simplifying involved. So I'm just going to multiply straight across, and then I'll simplify from there. 90 over 360 is 1/4. So I'm going to, because 9 over 36 is 1/4, so I get pi over 4. Now when I do this, I do not divide pi divided by 4. I just leave it pi over 4. So my answer here is that 45 degrees is the same as pi over 4, and I want to label it radians. Degrees is this label, radians is that label. So let's just check it out. Let's do the sine of 45 degrees on Google Calculator in a moment, and let's do the sine of pi over 4 radians on Google Calculator. Okay, so I'm going to clear this. There we go. All right, so let's do degrees first. All right, so the sine of 45 is equal to 0.707, blah, 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 blah. All right, now let's switch it over to radians. We're going to do the sine of pi divided by 4. And that's going to, oh, it says times. Sorry, sine of pi divided by 4. We're going to get 0.707, the same thing. So again, we're just using different units to express the same situation, okay? All right, let's practice some more. Here we're going to convert from radians to degrees. So 3 pi over 2 radians. Whenever I convert it to degrees, I'm going to put radians down here, degrees in the numerator, and fill in what that relationship is. 360 degrees for 2 pi radians. I can multiply straight across, I can cancel within. The one thing I will cancel for sure is my pi's. Now when I would personally do this, there's a lot of canceling I would do, but just to make it simplified, especially through video, I'm just gonna multiply straight across. Okay, so this gives me 1080 over 2 times 2 is 4. Okay, my radians cancel, so now 1080 divided by 4 gives me 270. So 270, let me actually write it like this. I'm going to rewrite it and say that 3 pi over 2 radians, again make sure you label that, equals 270 degrees. They are equivalent values. Okay? All right, let's try another one. Convert 15 degrees to radians. So 15 degrees. I'm going to put 360 degrees down here, 2 pi radians up here. Multiplying straight across, I get 30 pi over 360. My degrees are what canceled, so my answer is going to be in radians. So I'm going to leave the pi there. I can cancel out the zeros. 3 over 36 is just 1 over 12. So my answer is that 15 degrees is the same as pi over 12 radians. Okay, and now the last one, 4 pi over 3 is in radians. I want to convert it into degrees. So I'm going to put 360 degrees in the numerator, 2 pi radians in the denominator. That's going to allow for my radians to cancel. Multiply straight across. I'm also going to cancel out those pi's to eliminate some things. So 360 times 4 is going to give me 1,440 over 3 times 2, which is 6, divided by 6, and I get an answer of, oh, let me check that. So I think I hit a wrong button. Okay, 240 degrees. Okay? All right, so with that in mind, let's go ahead and let me just times 360 over 2 pi. Just a quick look to make sure everything here lined up, and I think we're all set. Do you ever get that funny feeling in your head like you made a mistake? You want to go back and check it, but we're all good. Okay, so now just a little summary to show you how this all relates. We're not going to get into what this is in detail. This is the unit circle. Okay, now you're going to do a ton with this in trig, but I just want to give you a little preview as to what it is. So in the unit circle, again, it's unit because our radius is 1. So that means this point here is 1, 0. This would be 0, 1, -1, 0, and 0, -1. Now let's think about it. If the whole distance around with a radius of 1 is 2 pi, okay, so the whole thing around is 2 pi, then halfway around is just going to be pi, right? Now half of that is going to be pi over 2. And if I see I'm counting, this is pi over 2, pi, if I add another pi over 2, I get 3 pi over 2. And then this would be 4 pi over 2, which is 2 pi. So 1 pi over 2, 2 pi over 2 is pi, 3 pi over 2, 4 pi over 2 is 2 pi. So that's where those values come in. And then I can break it down even further. I could go ahead and make this half of this, half of 1/2 is 1/4. So this would be pi over 4. And then I just start going around. 1 pi over 4, we don't put the 1. 2 pi over 4 simplifies. This would be 3 pi over 4. 4 pi over 4 just simplifies to that. This is 5 pi over 4. Then we have 6 pi over 4 is 3 over 2. And then moving on, we have 7 pi over 4. And then 8 pi over 4 is 2 pi. And then you can go further. You could break these into thirds. Okay, and we'll stop at this one because these are most common. I can say that this is, well, okay, so this would be, let's break it into 6 rather, okay? So I'm going to break these into 6 red spots. Okay, so if I look at the top half, I have this piece of the pie, which is pi over 6. Then I have here, this would be 1 pi over 6, oh, not that one, sorry. Then my next red one, I went to the purple one. Next one would be 2 pi over 6, which 2 pi over 6 is pi over 3. And then we have 3 pi over 6, which is 1/2. Then we have 4 pi over 6. Okay, so that would be this one here. And 4 pi over 6 is going to give me, if I just write it out, 2 pi over 3. And then I have 5 pi over 6. 6 pi over 6 is pi, and then this works into the bottom half. I have 7 pi over 6. And hopefully you're seeing the pattern. This would be 8 pi over 6, but that simplifies to 4 pi over 3. Then I have 9 pi over 6, which is this. Then we have 10 pi over 6, which is 5 pi over 3. And then we have almost lastly, 11 pi over 6. And then bringing us back up, we have 12 pi over 6, which is 2 pi. So anyway, my point is, these are the common ones. These are what you'll use a lot in trig. And you may even relate, what I want to do here is show you that this relates so much to what we've done this year, because this turns into, this is if we look at the degree measures and come back to what I highlighted, I'm going to write these in black. This is 0 degrees. This is a right angle, right? So this is 90 degrees. This is a straight angle, so this is 180 degrees. This goes 90, 180. This is 270 degrees. And the whole thing comes back to give me 360 degrees. Oops, 360 degrees. Then half of this is going to be, if this is half of 90, this is 45 degrees. So this is 45 degrees, 90, keep adding, this is 135, 180, and so on. If I would take a look at this one, this is broken into thirds. So this is 30 degrees. This here is 60 degrees. This is 90 degrees, 120 degrees, 150 degrees, 180. So we can figure out, and if you remember that problem we did, converted, one of the first ones was 45 degrees is the same as pi over 4. But what I want to get at real fast, just to show you kind of the connection to what you'll do later, 45 degrees, this is a 45, 45, 90 triangle. And then we can go ahead and use sine and cosine. I know that this is a 1, this is 1, and that helps me with that ordered pair. And so much of it starts to come together. Can you tell how excited I am by this? All right, we're at the end of the long lesson. Feel free if you have any trig questions to ask me. This is not needed for now. Okay, it was just extra for the good of the math. Okay, but great work with everything. Thank you for that, and I will look forward to talking to you soon. Thanks, guys. Bye-bye.